Okay, so took rule, everything is good. What I'm going to do right now is I am going to pull up the exam. So international students, if it goes pause for a minute or two, we will continue in just a second, but basically it's because I'm going to be going over the exam. Okay, so I'm pausing the recording now. We are now done with going over the test. We are now creating a new project in a new class. Name it anything you want, but it is going to be covering the last variable called Benjamin. What is it? Benjamin?
Boolean.
Boolean. Very good. All right, here we go. So we are covering Boolean. We are prepared for Boolean. Now, for my brilliant programmers from last year, who am I going to pick on? Runner Girl. Okay, you have dealt with this before. What is Boolean capable of holding?
True or false?
True or false. Very good. So I can say Boolean A equals true. Now, if you remember in Python, what was the difference? True had to be what?
Capitalized.
Capitalized. Make sure you remember that. That's the big difference. I can now say Boolean B equals, what's the other one? Benny Eisner, you're in a talking mood. What is it?
False with a capital F.
All right, lowercase. Very good, Benny. Smile. It's okay. Let those.
Oh, yeah. I said lowercase.
Now, Boolean B A equals true, Boolean B equals false. So if I print this out, okay, if I print out A, it's going to be true. If I print out B, it's going to be false. Okay, now this is just all I'm doing is I'm kind of showing you that Booleans can store true or false. But what you have to know is that 99,000 billion times out of 100 billion kajillion times, you are not going to ever do it like this, the true and false. Is there a possibility? Have I seen it on the actual free response section done? Yes, but not in years, okay? For the most part, we are going to be using our operators, all right? So that being said, let's have an introduction, okay? These are what we call logical operators. Now, Allie girl, what is that one? Come on, spit it out if you know it.
Subtraction.
Huh?
Subtraction?
No. What's that symbol?
Oh, it's greater than.
Dashes is kind of like to show what the definition is.
Greater than.
Are we sure about that?
Less than.
Less than. All right. Less than. All right. Okay. Kennedy, what is this one?
Greater than.
Greater than. All right. Perfect. Now, what you guys are used to is this. You're used to this. Okay. Now, Vasily, being the mathematical whiz that you are, what is this? This symbol that I just drew.
Oh, that's less than or equal to.
And Leo, what is this?
Greater than or equal to.
Very good. Okay. Now, let me clear this. Clear all drawings. Good. Okay. Now, we have to be phonetic because that symbol does not exist in Java. Okay. So what we have to do is say less than or equal to, like that. It's the less than symbol and the equal symbol. This is less than. We then need the greater than or equal to. Okay. Now, I've heard a lot of math students say that they actually prefer it this way because it's just phonetic, greater than or equal to. Unfortunately, that's not how it's done, but you can't have everything in life, okay? Now, who should we get? Oh, Armand. Hello, Armand.
Hi.
Okay. Now, what is this in algebra?
Not equal to.
Not equal to. Bingo. Okay, so we are not allowed to do that. There's no symbol in Java that allows not equal to. So instead, we use an exclamation point. This is how we say not equal to. And Nick Azizian. Oh, Nick, this is a two-parter. Nick, what is that symbol?
Equal sign?
Okay, it is an equal sign, all right? Now, that equal sign is, can we use this? Does that look good?
What do you mean? Can you use it for what?
Can I say A equals B?
No, you have to do two equal signs.
Exactly. One equal sign already has a role in programming, okay? It's called the assignment operator. It assigns a value to a variable, or it assigns a constructor to an object. Therefore, if we're doing comparison mathematics, we would say equal, equal, okay? So two equal signs is equal to. We have three more that we need to learn about. The first one, okay? This is the Borat operator. Not. Just nobody, nothing, not even a little bit. No.
It was good.
That was actually
It was good. It
that
was
was
good.
pretty good.
Was that pretty good? You like that? Good, thank you. All right, I like it when you guys lie to me. All right, this is the not operator. And basically, it's one of the things that where you would actually use it like a, it's like one of the ones where it's the few where the distributive property actually applies to it. You can apply it to something in parentheses, you can apply it directly next to something, and it just switches it around, okay? We'll go, so for example, right here, I have system.out.println b equals false, okay? If I apply the not to it, it flips it to true, okay? And then the last ones that I have are the ands, and means and then we have the ors, okay? Ands and ors, all right? Now, the ands and ors are for combination or combining multiple logical statements. That being said, so I'm going to get rid of these for a second. Let's say that I said int a equals 5, and I said int c equals 7. Now, with my logical operators, I would say Boolean z equals a is less than or equal to b, or sorry, c. And I would print z. So if I print this out, oops, equals a. Oh, whoops, I already used, yeah. There we go. Boom, true, okay? That is true. A is in fact less than 5. Boolean z is equal to a not equal to c. Also true, okay? Or let's say equal to c, okay? False, all right? So, hold on one second. All right, so now, this is 99,000% of the time how you are going to use conditionals. Now, notice how I stored it in a Boolean. I can also just use it in a print statement. Okay, I can just go ahead and use it just like that. Okay, a lot of like where you'll need to know these logical operators. All right. Okay, so that being said, let's talk about ands and ors very quickly. Okay, now let's say I'm going to make a scanner. All right, so I make my scanner. Here we go. And what I'm going to do is I'm going to ask, okay, let's see, who's my clubber in the class? Okay, Armand, how old do you have to be or to get into a club?
18,
No.
21.
21. Okay, so keep that in mind. We have 21. Okay, so they should be 21. Now, Kennedy, what type of, finish this off. How would I store the answer? Give me the type, variable name you would use, and the method.
Are you going to be adding anything else, or is it just going to be an int?
It's just an int. You know, just standard age. It's the most common sense answer.
Then int age equals kb dot next int parameter.
Bingo. Beautiful. Beautiful. Okay. So next thing I'm going to do is I'm going to say, do you have the cover charge? Okay. Now, if I have the cover charge, let's see. Who's my other clubbing person? Allie girl. Okay. Allie. Okay. Hold on. Oh, okay. Allie, if you have the cover charge, let's say I'm like, you're in the line for the club and I'm like, Allison, do you have $20? What's your answer going to be? It's going to be one of two. What's it going to be?
Yes or no?
Yes or no, right? So this is going to be yes or no. Oh, I keep doing that. What do I keep doing in my escape sequences? Okay, yes or no. So that being said, keep in mind that being said, okay, how am I going to store this answer? Benny, Eisner.
As a Boolean,
Wrong.
As a string.
as a string, and then parse it.
String. Why would I parse it? How am I going to parse yes or no?
What you gonna
No,
do
don't.
next?
Hold on. Calm down, baby birds. I'm going to feed you. Okay, here we go. You haven't used that line in a while. All right, here we go. So we're going to just say string cache equals, and I only want to use one scanner without crashing it. So Tokes, what method am I probably going to use? KB dot
Next, because it's a yes or no answer.
bingo. It's just a one word, yes or no answer, one word answer. Perfect. Okay, so string cache equals KB.next. So what I'm going to do is based on whether or not, if they can get into the club, true. If they can't get into the club, false. Okay, so let's take a look at our equation. We have two equations, two separate logical statements that we have here. So system.out.println, I'm going to say first, age is, now how would I finish this off? Runner girl, okay? I'm capable of being 21 to get into the club. What is my logical expression? How am I going to finish this off? Age is what?
Greater than or equal to 21.
Perfect, okay? Now it's LA, or let's say we're not in LA. Let's say it's another club, okay? Let's say Montana or something like that, okay? It's a little strict on the rules. So not only do you have to be over 21, but you also have to have the cache. So cache is equal to yes. Here's the problem. This will not work, okay? And the reason why is, one, they have updated Java to kind of allow this to work, but you will be marked off on the AP if you do this, okay? What is cache? Type of variable, Vasily?
It's a string.
String. I'm comparing it to a what? Starts with an L.
A literal.
A literal. Didn't we learn a method in the string class that compares strings?
Equals.
Equals. Now, okay, so Kennedy, you answered first. So let's see if you can elaborate more on this. What if I capitalize Y or capitalized N?
You got to do ignore case.
Bingo. Very good. Equals, ignore case. And I'm just going to put yes. Okay, let me clear my annotations. Hold on one second. All right, so, okay, this will return, if you remember, this returns a Boolean value, okay? Cache.equals ignore case yes. So this is the strict one. This is if you're in Montana and you're trying to get into the club. If I run this, okay, how old are you? So how old you got to be to get into the club, Isis?
21 or older.
So we'll say 25. Do you have the cover charge? Yes or no? Isis?
Oh, let's go with yes.
Okay, so yes. And I'm going to do, because you teenage kids love being trendy and characterizing only your vowels. So we're just going to say yes, and I hit enter. True, I can get in, okay? But let's say, this is, let's say, for example, you're trying to cheat this. This is just a regular club. I'm 21, but I don't have the cover charge. Am I getting in? Oops, 21 and no, false, not getting in, right? Okay, but again, we're in Los Angeles. So let's say you're trying to get into the club. And a lot of times cash is king, or you get in because you're legal. What's the more loosey-goosey, Tokes?
The what?
Or loosey-goosey of our logical operators? And is really strict. So which one is the loose one?
Or?
Bingo. Or. So now let's say I'm Ashton. I go to the club. How old are you? I'm only 18. Oh, but do you have the cover charge? Yes, I do. Hey, you're getting in. Typical LA club. All right. So that brings us to our truth tables. Okay. And I'm pretty sure for those of you who had Python last year, you remember these. So let's take a look. Okay. One side of the logical expression is A. So for example, in our code, it was 1 comparing the cash. The other side was comparing the age. So that's part A and that's part B. And remember that these can latch onto each other. So let's talk about and first. If side A is false, side B is false, it's false. If side A is false, if false B is true, then it's false. True in A, false in B, false. The only time that this is true is when both sides are true. That being said, yes, Mr. Perry. Uh-oh, you're muted.
You would think I know that by now. Thank you for inviting me, but I have a question while you're right there.
Yes.
You guys remember, does this look familiar from a different class and a different application, that table right there? Allison Howell, you're nodding your head. Where have you seen that before?
In the previous computer science class?
No, not computer science. A different class that every 9th grader took or takes.
Math.
Not math. Genetics in bio, right? With chromosomes. Do you guys remember this? Ben, you're nodding your head. Doesn't this look familiar? It's the same thing, right? Same logic. Sorry for interrupting, Mr. Martinez.
No,
Carry on.
no, not at all. Okay. So now the other one is the or one. So now going back to math, I know this is a tough question, but if 3 out of 4 are wrong, what's the percentage of the failure rate there?
75.
All right. Woo, Kennedy, you must be butter because you're on a roll. So, all right, now let's go to or. Okay, let's go to or. Okay, you have false on one side, you have false on the other. That is the only time that an or statement is going to be false. So if 3 out of 4 can be true, Armand, tough one, what percentage truth rate is this?
66.
I hate you. 75%, okay?
2 out of 3.
3 out of 4.
I heard 2 out of 3.
No, 3 out of 4. So you can be true. It's a little bit more lenient. Now, I know a lot of you remember this. So Mr. Perry, knowing this logic, you get to jump in on this as well, okay? So knowing the logic, let's say that I created 2 variables. Boolean A equals true. Boolean B equals false. Now, there are equations as well that, just like mathematics, what's the rule of mathematics that we have to follow when doing a long equation?
PEMDAS.
PEMDAS. There is also an order of operations for logical operators, okay? So we have not equal to, and or. So when you're doing an equation, that is how you do it first. So who can give, let's see, Vasily, give Mr. Perry a brief synopsis on what not does so that he can participate.
So not makes is the not operator. So basically it'll change whether it's true or false. So if it's true, but it's not true, like if you put the exclamation mark, then it.
For example, this just prints out, Mr. Perry, this just prints out like what the equation answer would be. So for example, this is true. So if I put not A, this would turn it to false.
True.
Okay, so now here, I know some of you remember these. Standard AP, typical AP question, easy for you. B and A, or not B, or B and not B. What prints out?
Which one takes precedence, Mr. Marty?
I just wrote out the precedence rules. Okay.
Did you say I could participate?
Yes, not yet. Hold the answer in though.
Okay.
All right. How many of you think it's true? Raise your hand. How many of you think it's false? All right, so this is what I want you to do when you see an equation like this on the test. Write it out. B and A. So we're going to do this equation first. B and A yields a what? True and a false. Knowing our truth tables, that will yield a false.
False.
We're going to skip this one, okay? B and not B. So basically false and true yields a true, okay? So that being said, not B is equal to what? True, okay? So if I say false or true is true, true or true is, this will yield a true. Who got true? Who made the mistake on using the nots? Who wants another shot at this? All right, here we go. Now, not A and, or not A and 5 is less than 6 and not B or A. There's a shortcut for this. There's a little bit of a trick for this. Okay? There's a little bit of a trick. You can't always do it with an and, but you can do it with an or. This is going to be true. If the equation ever ends on an or a, it doesn't matter what all of this is. Eventually, this is all going to have to compare to a true. If it's an ever, an or true, ever and or true, what's going to happen is that is going to take precedence, okay? So, oh, crap. Class is over, okay? Your homework, I just realized I went over. I did this in the last class. Your homework is 1 through 13, end of chapter 8, odds only. Do not fill in that truth table. 1 through 13, odds only. You have till tomorrow, okay? Till 10 a.m., all right? I will get all your tests back to you. Everybody thank Mr. Perry for showing up. Glad you could participate.
Thank you for inviting me.
Thank you.
Marty, which chapter?
Just chapter 8, 1 through 13 odds, okay?
Okay.
Right. Thank you.
Sorry I took you guys. Do not
Thank you.
hesitate to tell me I'm going over, okay? Bye, guys. Good meeting today. Good class.
Thank you.